Most of the universe is not stars, not galaxies, not light. It's nothing. Vast, silent regions of space so empty, they make the word lonely feel useless. Cosmic voids stretching hundreds of millions of light years across, with almost no galaxies at all. To human eyes, they are the closest thing the universe has to a pure abyss. And this isn't science fiction. It's reality. We've already mapped thousands of these voids and supervoids. They drift, expand, press against one another, and slowly reshape the large-scale structure of the cosmos. And right now, we live on the bright edge of one. So let's leave home. You accelerate away from Earth, past the planets, past the frozen edge of the solar system, out into the Milky Way, a spiral galaxy of roughly 200 billion stars. Around it, dwarf galaxies swarm like tiny companions. Ahead, Andromeda moves toward us, carrying its own stars, gas, and dark matter. Pull back further, and our galaxy becomes one member of the local group. More than 50 galaxies bound together across about 10 million light-years by gravity and an invisible scaffold of dark matter. Then farther still, clusters gather into superclusters. Filaments stretch across the dark. Matter forms a vast cosmic web, and between its glowing strands lie enormous bubbles of almost perfect emptiness. This is one of the biggest surprises in modern astronomy. We once imagined the universe might be roughly uniform on large scales, galaxies scattered like sugar in the dark. But when we mapped it, we found something stranger. A universe built like foam. Sheets and filaments of galaxies surround huge hollow regions, all connecting at dense knots packed with clusters and superclusters. The structure is beautiful and unsettling, because the deeper we looked, the clearer it became that the universe is mostly made of places where almost nothing happens. Welcome to the local void, a region near our own cosmic neighborhood, roughly 200 million light-years across, with far fewer galaxies than it should have. If emptiness could glow, it would dominate a huge part of our sky, and beyond it lie even larger voids. One of the most famous is the Buddha's supervoid, a cosmic desert nearly 300 million light-years wide. Large enough to contain thousands of galaxies, yet astonishingly empty. Now imagine crossing into the heart of a place like that. No nearby stars, no galaxy blazing across the sky, no bright river of structure in the distance. Just blackness, not the comforting darkness of night on Earth, where light is only hidden by distance and atmosphere. This is deeper than that. A darkness so complete it erases direction, scale, and almost any sign that the rest of the universe exists at all. To human eyes, this is what most of reality would look like. Silent, airless, nearly featureless dark. But voids are not truly nothing. Even here, faint threads of dark matter and thin wisps of gas can remain. And sometimes, hanging alone in the emptiness, are void galaxies. Small, isolated galaxies, drifting like lonely blue sparks in a black ocean. They are among the rarest galaxies we know, and they may matter far more than they first appear to, because voids do not just sit there, they grow. At first, that sounds backward. If galaxies are racing through space at enormous speeds, shouldn't some of them wander into voids and fill them in? Usually, no. The reason is gravity. Not because it stops working, but because there is so little mass inside a void that the matter around the edges pulls much harder than the emptiness within. Galaxies near the boundary are tugged toward the denser filaments and clusters, not deeper into the hollow. It's like a tug of war where one side barely exists. So over cosmic time, voids tend to become emptier, while their edges become sharper and richer with structure. Matter flows outward toward the walls. The bright parts of the universe get brighter. The dark parts get darker. That makes voids some of the best places to study one of the strangest forces in the cosmos: dark energy. Dark energy is the name we give to whatever is causing the expansion of the universe to speed up. Inside galaxies and clusters, gravity is strong enough to dominate local motion, so dark energy is hard to notice directly. But in voids, where gravity is weak and matter is scarce, its effects become easier to trace. Here, emptiness expands with fewer obstacles. Here, the cosmic web is stretched thinner. Here, the universe shows its hand. As voids swell, nearby walls and filaments are pushed farther apart. Smaller voids can merge into larger ones. The architecture of the cosmos slowly frays, not in a violent instant, but over unimaginable spans of time. And that gives voids a strange double identity. They are the loneliest places in the universe, but they may also be among the last stable refuges in it. In crowded regions like galaxy clusters, gravity is chaotic. Galaxies tug on each other, collide, strip gas away, and trigger waves of violent change. But void galaxies live quieter lives. They tend to be smaller, bluer, and rich in gas, forming stars more slowly and more gently than galaxies in denser environments. They age in slow motion. Far in the future, that may matter. As the universe continues expanding, galaxies beyond our local gravitational neighborhood will slip out of reach. Star formation will decline. The great bright era of the cosmos will fade. And in that long twilight, the calm, isolated galaxies inside voids may be among the last places where new stars can still form. The last star ever born may ignite in a place like this. Imagine the distant future. A civilization older than worlds, watching the rest of the universe disappear beyond the horizon, searching for any place where time can be stretched just a little longer. A lonely void galaxy might be the final safe harbor. Not a paradise, just the last quiet room with the lights still on. And eventually, even that ends. Far down the timeline, voids will keep expanding. Supervoids will grow, merge, and dominate more and more of the observable universe. The bright web of matter will be pushed farther apart until almost everything beyond a local island of galaxies is gone from view. The cosmos will not end in fire. For most observers, it will end in distance, in darkness, in silence. Which is what makes this moment so strange. You are alive in the brief era when the universe is still visible, when galaxies still fill the sky, when structure still surrounds us, when the lights are still on. We are not living in the universe's final emptiness. We are living in its bright exception, a small world around an ordinary star, inside a thin strand of matter, on the edge of an ocean of nothing. And somehow, that doesn't make life feel smaller. It makes it feel precious. The loneliest places in the universe remind us of something simple. That against all this darkness, to exist at all is astonishing.